Well, Dr. Vaughn, we're going to do a couple of videos this week on the homework 3, homework 4. I think that you'll find these homeworks pretty challenging. They're some of the hardest ones you're going to have really for the whole course, I think. So I don't mean that to scare you. I'm just trying to make sure that you go into this week knowing that you have a significant challenge in front of you. So in this case, we're looking at the Roman numeration systems. We'll do a few questions here, and then I'll stop it, and later this week we'll make another video. So the Roman numeration system, you're going to want to have the key in front of you. You know, the letter C stands for 100 in Roman numeration. So we're going to start with the 300. So that's going to be 3 C's. And then 50 in Roman is going to be the letter L. And then the 5 in Roman is going to be the letter V. So I think that the correct answer here is C, 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 L, and V. All right, so now we're looking at counting in bases. And so this is a good introduction to much of what we're going to do in alternative base systems. We'll use alternative base systems for addition, for subtraction, and even some multiplication. Now, in a base 5 system or a base 8 system or a base whatever system, you only use the symbols up to 1 less than whatever that base is. So you actually have 5 digits, right? Because you're using the 0 as one of those digits. So 0, 1, 2, 3, 4 is actually 5 different digits, and that's what makes it a base 5 system. And as soon as you get to 4, then you bump over into the next position. So you have 1 in the 5's digit and 0 in the 1's digit. It really does help on these problems if you start to think of these things in terms of base blocks. So look in your text about the idea of base blocks and the whole idea of the positional value system you have in the base 10 system is that as soon as you get to 9, you add one more to that, and you have what you and I would say as the word 10, but that's really 1 unit of the 10's digit and then 0 of the 1's digit. So it's the base value that's determining the value of the next place value. So as soon as I get to 5 in base 5, I'd have 1 5 and 0 leftover ones. I'd trade in my units for 1 long is what we'd call it, which is 5 of these things glued together, the next place value up. So after you get to 4, the next counting number after that is going to be 1, 5, and 0 ones. So let's start with the first 15 counting numerals for base 5. So you go 0, well, counting numerals, we're going to start with 1, 2, 3, 4. And then after 4, we're going to trade it in for 1 unit of 5 with 0 left over. So we're going to have what you and I would call 10. But I want you to really think of this as 1, 0, 1, 5, and 0 ones. Okay, then we'd have 1, 5, and 1, 1, 1, 5, and 2 ones, 1, 5, and 3 ones, 1, 5, and 4 ones. Now after that, we're going to go to 2 5s and 0 ones. And we'll continue counting up like that. And I want to keep doing this until I get to the 15th counting numeral. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need 5 more. All right, so we'll go 2, 1, 2, 2, 2, 3, 2, 4, and then 3, 0. And I think that that's the first 15 counting numerals in base 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah. All right, let's go ahead and check that answer. And now we'll do the same thing in base 8. So in base 8, we go 1, 2, 3, 4, 5, 6, 7. Now we get to 8, and so we have to do 1 unit of 8 with 0 left over in the 1's digit, 1 unit of 8 with 1, 1 unit of 8 with 2, 1 unit of 8 with 3, 1 unit of 8 with 4, 1 5, 1 6, 1 7. And now that should be, let's see, 14. That's actually 15 numbers right now. The next one after that would be 2, 0. But I think that that's 15 counting numerals, 1 through 7, 8, 9, 10, 11, 12, 13, 14, 15. So you don't have to go any beyond that. All right, we'll try one more of these questions. Let's see how many digits are needed for the base 9 system. So in base 9 system, you actually need 9 digits. You're going to have 0 through 8 are the digits that you're going to use in a base 9 system. Okay, and let's work through this one. This is actually one that a lot of students have asked me about in the past. And so this is a long question, and there's lots of parts to it. It's going to be hard to just simply orate, but I'll do the best that I can and try to talk our way through it. So when we subtract 1, the number preceding 770, you want to take 1 away from the 0. Now, you can't really take 1 away from 0, and so you actually have to borrow. You have to cash in one of these 7s So now I have 6 of them over here to get 8 in the ones digits. So I'm going to have a 7 and then a 6 and then a 7. And now the next one, to add 1 to it, you're just going to put 1 in the ones digit, and you have a 0, so you can add 1 there without having to bump anything up. Think about this in terms of borrowing and cashing in, like trading in place value. Think in terms of base 10 place value, and then you're doing the same thing. It's just you have to borrow or cash in as soon as you get to 8 instead of 10. So the number that's after 770 would be 771. All right, let's try 1000 with a 4. So the one that's before that, I need to cash in this, take 1 away from this 0. I can't take 1 away from 0, so I have to borrow. I don't have anything 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 to borrow. So I go all the way over here to this 1, and I'm going to cash it in for 4 in this position. And so that's going to leave me with 1, 2, 3, 4 place values to the right of this 4. And then that 4 is actually going to become a 3 because I have to trade in 1 of those for 4 of the next one down, and then trade in 1 of those for 4 of the next one down, and so on and so on. So the number that's before 100000 is going to be 3, 3, 3, 3, 3, 5 threes. And you can think about this by bumping this up. That'll become 4, which you have to trade in to 0, and make that a 4, which you have to trade in, etc. Now, the one that's after this is a lot easier to do because you can just add 1 into the ones digit. 1, 1, 2, 3, 4, 1. And for the last one, E is standing for the 11 in this base 12 system. And the number that's before 11 is 10. So the number that's before EEE is EET. But it's adding 1 in this case that's going to be a little bit more of a challenge, because when you add 1 to 11, you get 12. We're in base 12, so that means I'm going to have to put 0 in the ones digit. That's going to make this add 1 to it from carrying over. That 11 is going to become a 12, so that's going to become a 0. Add 1 to here, that's going to become a 12, so makes that a 0, and I'll have 1 now in the 4th digit over. I'm going to have 1 unit of 12 with these 3 zeros that have been created by the successive carrying over into the next digit by bumping this up by 1. So I think I have 1000. All right. Well, I think that's been a good introduction to the idea of preceding and succeeding, this idea of alternative base systems, and we touched a little bit on the Roman numeration system. I'll catch you next time.